Circle C, it says, has radius 5 and its origin as the center. Okay, now what I've done here, I've drawn sort of like an accurate sort of sketch. So I'm going to start to draw it with an axis system here for all the values I need. So circle radius 5. So what I'm going to do, I'm going to draw it accurately. You don't need to do this in the exam, right? But sometimes it helps to draw sketches accurately. Okay, especially with the coordinate geometry type questions. In this case, it's a circle geometry question, but you'll see now, perhaps as a sort of teaching perspective, how it might help me drawing this accurately for you. So I've got here circle, and it says of radius 5. So I literally measured this out on my ruler to be 5 centimeters. Okay, and it says then the point T has coordinates 11, 0. So literally that's going to be 11 up there, right? So that's where point T is. Okay, so I've measured 11 centimeters up. Okay, and here's my circle of radius 5. So it says the tangents from T to the circle C touch C at the points R and S. So that it says the tangents from T. Now you know a tangent is a straight line from T. Okay, so the tangents are going to touch the circle. So from T here, literally like that, yeah? So it's going to touch the circle. So I'm going to see if I can draw this as good as I can here. So it touches the circle. Yeah, I think that's about right there. So that will be maybe my point R. Okay, and then of course there's another tangent then from T. That would be my, so maybe go there. That would be my point S there where it touches here. Okay. Fantastic, and I've got my origin here, haven't I? So it says then, write down the geometrical name of the quadrilateral ORTS. So ORTS, well, let's create it. O to R I need. Okay, O to R, R to T, T to S. Let's join that up to create my quadrilateral. What's the name of that quadrilateral, they say? Okay, well, before we name it, we need to recognize here that these are 90 degrees, aren't they? Because this is the tangent meets the radius at 90 degrees. Okay. So we got to recognize what that shape is. All right. You might recognize that it's a kite. Yeah. Okay. So a kite is symmetrical along this line here. Okay. These two angles are 90 degrees. Okay. And then the opposite angles here. So all of that and all of that then. Okay, will add up to 180 degrees. Okay, but it is indeed a kite, so we write that down there. Okay, and a kite, quite simply, just has a line of symmetry. Okay, one line of symmetry. So we've got then part B. It says find the exact value then of the area of quadrilateral ORTS. Give your answer in its simplest form. Now, when it comes to a kite, what I like to do is split it up into two triangles and think of it that way. And once you work out the area of one triangle, you just double it because that triangle is exactly the same. It's symmetrical. The good thing is I know that distance there is 11, don't I? Okay, I know that distance is 11 because we've got the value of T to be 0, 11, the coordinate. But the other thing as well, I know that this side is 5, okay? Because of course it is the radius of the circle. Now, we've got a right angle triangle, we know two sides. Can we work out the third side? Well, of course we can, because we can use Pythagoras. And it is important to work out that third side, as you'll see now. So with Pythagoras, remember a squared plus b squared is equal to c squared. So in this case, my C is the longer side, yeah? Always C is the longer side, which is going to be 11. My B then will be 5. And then my A then, well, we'll work out now. So that means then, A squared is 11 squared, take away 5 squared. So A then is the square root of all this. So we get our answer to be 4 root 6. Okay, so that's what that side is there. Now, to get in the area of the triangle, well, remember, area of triangle is half base times height. So when you see this here, that's going to be my base, that's going to be my height. You can turn it around to see that there, my base and height. So it'll be half times 4 root 6 times 5. So that'll be 10 root 6. So that's the area of one triangle. To get the area of the kite then, you just got to double that because it's two triangles, so it'll be 20 root 6.